This is an intro to quantum tunneling. Imagine you're by a hill with a cookie bakery on the other side. You really want some warm cookies after a long hike, but are too tired. You need energy to pass a physical barrier. This is an example of classical mechanics, but what if there was a way to pass right through this barrier with much less energy used? Well, quantum mechanics says yes to that. But before we jump into it, we need to look at scale first. This is you. You are macro, and so is your phone, and so is the chip inside your phone. The atoms that make up the chip? Maybe. But the electrons and protons that make the atom? Now that's the micro scale of quantum mechanics. Let's take electrons as an example to understand quantum tunneling. Electrons are particles that make up matter, but on a quantum level, they can also behave like waves, which allows for a small non-zero chance for them to pass through and appear and exist on the other side of a barrier. There are some conditions, however, for quantum tunneling that are important to consider, like the speed and energy of the electron in question, the height or thickness of the barrier that exponentially affects the process, and of course, some rules of quantum physics. But let's say we have all of that checked out. So, what actually happens? Well, when an electron tunnels or passes right through a barrier, it exponentially decays during then. Exponentially, as in like a roller coaster going down, and decaying, as in almost kind of dying. But it doesn't. It bravely passes through, kind of like Monica Rambeau from WandaVision, if you get the reference. And when it comes to the barrier, they can either be physical, made of atoms, or even energy barriers. For example, inside our sun, where inside the core, hydrogen protons have energy barriers due to electrostatic repulsion. Quantum tunneling actually plays a key role here, still enabling nuclear fusion, leading to the creation of helium and a lot of energy, like the sunlight reaching us. And this sunlight is why we have life. Speaking of which, quantum tunneling is also known to happen in photosynthesis, where near to 100% of the energy transfer efficiency is reached for excited electrons to find the fastest path from chlorophyll to the reaction center. Quantum tunneling also happens in us, in our DNA, and specifically in the hydrogen bonds that attach nitrogenous base pairs, the bases for genetic code, together. The phenomenon makes hydrogen protons to accidentally skip through the energy barrier, leading to shape changes and rare spontaneous mutations. Understanding of quantum mechanics has just begun, with 2025 being the field's just 100th year anniversary. And in fact, in 2025, the Nobel Prize for Physics was awarded for the discovery of macroscopic quantum tunneling and energy quantization in an electrical circuit. There's so much more. But for now, when facing a barrier, just know that even nature says there's always a non-zero probability of making it to the other side.